In this module, you will learn about velocity time graphs. In this module, you will learn about velocity time graphs. Like the distance time graph, the variation in velocity with time for an object moving in a straight line can be represented by a velocity time graph. In a velocity time graph, time is taken on the x-axis while velocity is taken along the y-axis. Using a velocity time graph, you can determine the nature of the motion, the velocity of the body at any instant, displacement of the body as the area under the graph, the instantaneous acceleration, and the equations of motion along a straight line. Let's consider the different cases that can be represented by a velocity time graph. Body at rest. Body with uniform velocity. Body with uniform acceleration. Body with non-uniform acceleration. And body with uniform retardation. The displacement is 0 for a body at rest, and hence the velocity is also 0. A velocity time graph plotted for a body at rest displays a straight line along the x-axis. When a body moves with uniform velocity, there is no change in the velocity with respect to time. Therefore, the velocity time graph for a body with uniform velocity will be a straight line parallel to the x-axis. The point where the line intercepts the y-axis shows the magnitude of the uniform velocity of the body. When a body starts from rest and exhibits uniformly accelerated motion, the velocity time graph represents a straight line passing through the origin and subtending an angle with the x-axis. This is because in this motion, the velocity of the body increases uniformly with time. Let's assume that the body has some initial velocity. This body then moves with uniform acceleration. In this case, the velocity time graph of the body is a straight line intercepting the y-axis and making an angle with the x-axis. Thus, the velocity time graph of a body with uniform acceleration is a straight line making an angle with the x-axis. The velocity time graph for a body moving with non-uniform acceleration is a curve and not a straight line. The velocity time graph for a body moving with uniform retardation is a straight line making an obtuse angle with the x-axis. The area under a velocity time graph gives you the displacement of the body in a given time. Consider the velocity time graph of a car moving with uniform velocity, say 20 meters per second. To determine the displacement of the car between points A and B, which represent the position of the car at durations 20 seconds and 30 seconds respectively, draw perpendicular lines from A and B to intersect the x-axis at point C and D respectively. The time taken, t, by the car to move from the position represented by point A to the position represented by the point B is the difference of time t2 and t1. We can say AB is equal to CD is equal to t2 minus t1 is equal to 30 minus 20 is equal to 10 seconds. Since the car is moving with a uniform velocity, the magnitude of its velocity is the same at all points on the graph. Velocity V is equal to AC is equal to BD is equal to 20 meters per second. By definition, the velocity of an object is the ratio of displacement to time. Therefore, we can say that displacement is the product of velocity and time taken. Substituting V and T in the expression S is equal to Vt, we get S is equal to AC multiplied by AB. This is nothing but the area enclosed in rectangle ABTC under the velocity time graph. Thus, in this case, the displacement of the car is equal to 20 meters per second multiplied by 10 seconds, which is equal to 200 meters. Similarly, you can also determine the displacement of a body moving with uniform acceleration. Consider the velocity time graph. To determine the displacement of the body between points A and E, from both points A and E, draw two lines parallel to the y-axis, intersecting the x-axis at points B and C respectively. From point A, draw a line parallel to the x-axis to intersect the line CE at D. The area under the velocity time graph between points A and E is the sum of the areas of the rectangle ABCD and the triangle ADE. The area of the rectangle ABCD is the product of its length AB and its breadth BC. The area of the triangle ADE is half the product of its base AD and its altitude DE. Hence, the displacement is equal to S is equal to AB multiplied by BC plus half of AD multiplied by DE. This brings you to the end of this module. In this module, you have learned that in a velocity time graph, time